Okay, exercise number 1. Noah and Carter are collecting box tops for their school. They each bring in one per day starting the first day of school. However, Carter has a head start because his aunt sent him 15 box tops before school began. Noah's grandma saved 10 box tops, and Noah added to those on the first day of school. So, this is telling us that, Carter started with had saved 15 before school. Noah's grandma saved 10, and then they each brought one that first day of school. So on the first day of school, Noah has 11 box tops and Carter has 16 box tops. So we know that it says they each bring in one per day. So it says fill in the missing value. So I know they each bring in one per day. So Noah will be he'll bring in another one on the second day of school. So 11 plus 1 is 12, and then 12 plus 1 is 13. So we just add one every single day. Okay, and then we have Carter's box tops. He starts with 16, and he's bringing in one every day as well. So 17, 18, 19, and 20. Okay. So if we let D be the number of school days since the school year began, on day D of school, how many box tops will Noah have brought to school? So this is saying that we're going to use the letter D for the days of school. So I'm actually going to use a lowercase d. So school day. I'll actually put D right here in parentheses. So we know that the school day is D. And so how can I write an expression for that? Well, he brought how many to start with? Well, he had, should be D plus 10. Okay, now how does that become 11 on the first day of school? Well, because it says that Noah's grandma saved 10 box tops, and he added those on his first day. So day 1 plus the 10 that his grandma gave him. So he had the 10 he started with, first day of school, so that gives you 11. On day D of school, how many box tops will Carter have? Well, it looks like Carter, he had, his aunt sent him with 15 box tops, and then he had that extra one that he brought on the first day of school. So his is going to be D plus 15. D plus 15. He's got the 15 that his aunt sent him with, and then one for every day he's in school. So this next one says, on day 10 of school, how many box tops will Noah have brought to school? And so this is when these actual expressions become really handy, because we can solve things for like on day 10 without having to expand this table out or trying to figure out some unit rate between everything. And that just gets, that we've done that before, and that can get kind of messy, especially if they're not even numbers and stuff. So we can use these nice expressions. So this is Noah's, right? This was Noah's. And let's actually make Carter blue. So he's going to be D plus 15. So on Noah is D plus 10. So D plus 10. So his is going to be on day 10 of school, so 10 plus 10, we just substituted in, we just put a 10 in the place of the D for the days, and then that's 20. So 20, so we can say so Noah has 20 box tops on day 10. on day 10 of school, how many box tops will Carter have brought to school? So we are going to be taking the number of days plus 15. So that would be 10 plus 15. So 10 plus 15 is 25. So Carter will have 25 box tops on day 10. Okay. And next. Each week the primary school recycles 200 pounds of paper. The intermediate school also recycles the same amount, but had another 300 pounds left over from summer school. The intermediate school custodian added this extra 300 pounds to the first recycle week. Okay, so it says each week, here we have, each week the primary school recycles 200 pounds of paper. So let's go ahead and start filling out this table. We've got, let's say week 1, 2, 3, 4, 5. And we know that the primary school is bringing in 200 a week, so that one's pretty easy to fill out. So we have, on week 1, we have 200. So week 2, they bring in another 200, so that would be 400. And then week 3, another 200, so 600, 800, and 1,000. Okay, now we have to fill out the intermediate school, or as we would call it, middle school. And this says up here, the intermediate school also recycles the same amount, but had another 300 pounds left over. So, and it says the school custodian added this extra 300 pounds to the first recycle week. So they recycle 200 pounds, just like the primary school does the first week, but then they had this extra 300 pounds. So to start, they are going to have not 200 pounds, but they're going to have 500 pounds. So they have 500. And then they are also, it says, they're also recycling the same amount of paper. So they start with 500, but, week 2, they recycle another 200. So 500 plus 200, 700. Then week 3, they recycle another 200 pounds. So that's 900. It just keeps continuing. 1,100, 1,300. Okay, if this trend continues, what will be the total amount collected for each school on week 10? So if you need a second, or I'll just give you a second to think about it. So check it out. Week 10. How much will you need? If you want some more time to try and think about it, then go ahead and pause it, but I'm going to move on. So, some of you might be looking at these things and you're like, well, I see that week 5 is half of 10, and so if they saved 1,000 in 5 weeks, then in 10 weeks the primary school should be able to save 2,000, and if the intermediate school saved 1,300 pounds, then in 10 weeks, if they recycled this much in 5 weeks, then in 10 weeks they should also be able to recycle twice as much. And that's good thinking, but that doesn't actually work. So one way that you can think of that same comparison is, between when we went from week 1 to week 5, how many weeks was that? Well, that was 5. So 5 is 5 times the size of 1. So is 1,000 also 5 times is 2,000, is 200 times 5 1,000? Yeah, it is. But is 500 times 5 1,300? No, it's not. So that whole little, the multiplying to go down the table, that's not going to work because this whole column over here isn't really working that way. So what we have to think of is, really what kind of expression can we write for that? So to do that, to write an expression for both of these, we can first think of what's an expression for this one. How can I figure out how many pounds I am getting depending on how many weeks? Well, you're noticing if we completely ignore all this over here, we're just looking right here, we notice that the number of weeks, can you multiply to go between these columns? And yes, you can. This times 200, this times 200, this times 200, right? 1 times 200 is 200, 2 times 200 is 400, 3 times 200 is, 3 times 200 is 600. So since we know that they're getting 200 pounds of paper every week, the primary school, and in this case I'm going to use a capital P for primary school. It actually stands for the primary school, the actual school. So that's going to equal the number of weeks times 200. Or 200. When we could actually say that is, we're thinking that is actually 200 W, which would be a better way to write that. Just the simplified, this would be this simplified with 200 for our coefficient. Now, this is the expression right here. This is the expression for the primary. How do we end up going from the primary right here? How do we go from here to here? Well, if I'm looking at this column, these numbers are always 300 pounds more than this column because we started with 300 pounds more. So since we started with 300 pounds more this week, 400 plus 300 is 700, 600 plus 300 is 900, it's always just going to be 300 more. So if we know that this is the same as this, right, we can find the number of weeks in the primary by doing this. How do we get the intermediate school? Well, we can just add 200 to this guy right here. So for the intermediate school, we can just use the same expression for the primary school, which is 200W, except then we can add plus 300, and that will help us. So if we know the number of weeks, we can figure either one out. So it says for each school on week 10. Well, week 10, I'm going to write that up here. Week 10. So for the primary school, week 10 would be, we would use this expression right here, and that would just be 200 times 10. So since we're just multiplying times 10, we can just add a 0. So that would in fact be 2,000. And for the intermediate school, we can use this expression over here, or this equation, or this, formula, really. The intermediate school is going to equal, this is the kind of the amount that the primary school has plus 300. And that would be, 200 times W, we already know that that's 2,000, so 2,000 plus 300 is 2,300. So, is it really necessary to actually come up with this thing? Not really. That was an extra step I was doing because you could just figure this out, which is actually the easier one to figure out, and then just add 300 to it. But I just kind of wanted to show you that you could actually also come up with an expression to solve for this, even if you didn't have this. I could solve for, if we know that there is 20 weeks, we could just do 20 times 200 plus 300 to get for the intermediate. We don't actually have to figure this one out first. Okay, moving on to the last one. Number 3. Shelley and Kristen share a birthday, but Shelley is 5 years older. Make a table showing their ages every year, beginning when Kristen was born. Okay, so first we can put in there. First we can write their names in. So let's go with Kristen's age. Age. It's in years. And we're going to have Shelley's age. also in years. It's important that we actually put those years there because it could be, I mean, we measure age in years all the time, but you could also measure how old someone is in months or decades or something like that. So, back to what it says. Shelley and Christian share a birthday, but Shelley is 5 years older. So let's just say we're going to start with when Kristen was born. So she's born, she is 0 years old, right? You're born at 0 years old, not 1. So 0, 1, 2, 3. Shelley's age is going to be plus this plus 5. So 0 plus 5 is 5. 1 plus 5 is 6, 7, 8. Okay? So if Kristen is 16 years old, how old is Shelley? So instead of continuing this table out, we want to write an expression. So what is our expression? So Kristen, we can say that Kristen's age, let's use, we'll use K for her, variable K. And so what is Shelley's age? Well, it's going to be that same K. Shelley's age is going to be K. I'm writing these under the tables just like as an extra column. So Kristen's age is K. Shelley's age would be Kristen's age, right? Her age, but plus 5. She's 5 years older. So Kristen is 16. So that's going to give us, we're going to use this. Kristen's age is 16. So we have 16 plus 5. So 16 plus 5, 21. So if Kristen is K years old, and so I kind of did this already. If Kristen is K years old, how old is Shelley? And that is this thing right here. So we already did that. Kristen is K, Shelley is plus 5. And then if Shelley is S years old, how old is Kristen? So this one is going backwards, right? So this is kind of like in the example in class. So this time we're going to say Shelley's age. Shelley, how can you figure out Kristen's age if you know what Shelley's age is? Well, if I'm looking up here, her age is 5 years less than Shelley's age. So if I start with Shelley's age to find Kristen, I just subtract 5. So it would be Shelley minus that 5. So, and that would give us Kristen's age. All right, that is it.